Hello everyone, and welcome. Today, we are going to break down a fundamental concept in organic chemistry, protonation. It might sound complicated, but it is a simple idea that shows up everywhere, from basic acid-base reactions to complex multi-step synthesis. So, what is protonation? At its core, protonation is simply the act of adding a proton to an atom, ion, or molecule. In chemistry, a proton is a hydrogen ion, written as H+. It is a hydrogen atom that has lost its single electron, leaving just the positively charged proton behind. These protons typically come from an acid, which is a substance that donates protons. The molecule that receives this proton is usually a base, or more specifically, a molecule with a spare pair of electrons, called a lone pair. A great example is the water molecule, H2O. The lone pair of electrons on the oxygen is electron-rich, and it is attracted to the electron-poor, positively charged proton. The mechanism is all about the movement of electrons. The electron-rich lone pair on the base reaches out and forms a new covalent bond with the proton. For instance, when water gets protonated, the oxygen's lone pair forms a bond with H+, creating the hydronium ion, H3O+. But why is this so important? Protonation is a powerful tool because it dramatically changes how a molecule behaves, and there are a few key reasons for this. First, it can make a bad leaving group into a great one. Take an alcohol, for example. The OH group is a terrible leaving group on its own. But if you protonate the oxygen, you get OH2+. This group can now leave as a stable, neutral water molecule, which is a fantastic leaving group. This step is essential for many substitution and elimination reactions. Second, protonation can activate a functional group for attack. Consider a carbonyl group, the C equals O double bond. If you protonate the oxygen, you pull electron density away from the carbon atom. This makes the carbon much more positively charged and a much more attractive target for an incoming nucleophile. This is a key first step in countless reactions. Third, protonation can change a molecule's solubility. Many organic molecules, like amines, are not very soluble in water. But if you protonate the amine, you turn it into a charged ionic salt, which will dissolve much more easily in a polar solvent like water. This principle is used all the time in medicine to make drugs more soluble. Thank you so much for watching. If you found this video helpful, please hit the like button, subscribe for more chemistry tutorials, and feel free to drop any questions you have in the comments below. Your support really helps the channel grow. See you in the next video.